Okay, fifth graders, today is Tuesday, November 19th, 2019, and we're adding on to what we did yesterday in Module 2, Lesson 24, with Lesson 25 today. Okay, yesterday you learned how to divide by multiples of 10, how to divide decimals, and I reminded you how those numbers shift on the place value chart. Do you guys remember that? Yes? Today we're going to add on to that, and kind of it's going to maybe remind you a little bit of what we learned earlier this module about estimating the quotient. Okay, so today what we're going to do is we're going to use what we know about math facts to help us estimate the quotient. Let's remind ourselves really quickly, what is a quotient? With a quiet answer hand, for estimating the quotient, we need to know what a quotient is. So what in the world is a quotient? Addison?
It's the answer to a division problem.
It's the answer to a division problem. So we're going to not find the exact answer today, but we're going to be estimating. Okay? But let's start by talking about the problem of the day. So let's review what we know about estimating quotients. When we're trying to estimate the quotient, we know that in a division problem there's a whole and there's a divisor, yeah? Because Ms. O told us many, many times, we now know whenever we're estimating a quotient, Audie, which part do we round first? Divisor. So if in my first problem there that you should write down in your notebook, 39.1 divided by 17, what is the divisor? Everyone?
17.
Okay, which is pretty close to what divisor that's easier to work with? 20, good. Okay, so let's look at 39.1. That's our whole. Is it close to something that is compatible to 20? 40, good. Okay. Hey, I have a multiple of 10, so that's the same as 40 divided by 10 divided by 2. Do you guys agree?
Yes.
So let's do the 40 divided by 10 first. What is 40 divided by 10?
4.
So this is equal to 4 divided by 2, or 2. So 39.1 divided by 17, a good estimate for that quotient would be 2. Now, I have a second problem over here. It's 3.91 divided by 17. I want you to take a look at that problem, write it down right next to it in your notebook, and then look at it. How does it compare? What's the same about it, those two problems, and what's different about those two problems? Please talk to the people around you. Okay, I heard some really good comments. I heard people notice that the divisor was the same. Do you guys notice that the divisor is the same? They're both 17. Yeah? I also heard people notice that it's the same digits in the same order. 391, 391. But the difference is where the decimal point is. Right? So let me ask you guys, are the two wholes exactly the same?
No.
But they both have 391. But because the decimal point is in a different place, they have different values, huh? So how does we have a different whole? How does the value of 39.1 compare to the value of 3.91? Well, 3.91 is 10 times smaller than 39.1. Okay? So let me ask you a question then. Before we even estimate, before we even solve it, how do we think the second quotient will compare to the first quotient? It's like saying if I took something and I shared it equally amongst the circle table, right? They each get a certain amount. Yes? Ecox, can you handle it? Thank you. Now let's say I start out with less stuff and I still want to share it equally. Will they still have the same amount as they had before?
No.
Are they going to have more or less?
Less.
Yeah. And if I have 10 times less, let's say I had $10 and I want to share it equally. They'll all get a certain amount, right? But let's say I start out with 10 times less than $10, which would be how many dollars? $1. How much less are they going to get each? 10 times less, because I'm starting out with 10 times less to give them. Do you guys agree? So how will the second, knowing that the whole is 10 times less than the original whole, how will the quotient compare to the original quotient? It's going to be 10 times?
Small.
What is 10 times less than 2?
0.2.
Okay, now let's do our estimation and see if we actually get 10 times less, which is 0.2. So we still round the whole first, so 17 is still close to, the divisor first. 17 is still close to?
20.
Okay. Now, 3.91 is pretty close to what number? 4. So this is like doing 4 divided by 20. Now, wait, 4 is too little to divide by 20, right? I can't. 4 is smaller than 20. How can I divide a whole that's smaller than the divisor? I can't. Could I rename 4 ones? Could I regroup it? 4 ones can become 40. Oh, so could I rename this as 40 tenths divided by 20? Is that the same thing? Yeah. Okay, so then I have 40 tenths divided by 10. divided by 2. Just like before, I can break it apart, right? What's 40 tenths divided by 10? Well, what's 40 divided by 10?
4.
So this is 4 tenths divided by 2, which is 2. Oh, is that what we predicted? It's 10 times smaller.